10 years and safe handling methods to reverse plummeting sales. Central California's San Joaquin Valley is the richest farm belt in the world. Its mild climate and nearly 6 million acres of farmland play host to some 350 different crops. Harvesting these crops requires a delicate balance of mechanization and hand labor. Where machines can't feasibly do the work, farm laborers, usually hired on a temporary basis, provide the muscle. For decades, California has depended on its neighbor to the south to supply the workers. The stream of Mexican labor began during World War II, when Franklin Delano Roosevelt initiated the Bracero program. Known as the strong-armed ones, the Braceros were a temporary labor solution to replace farm workers drafted for war. The solution proved not so temporary, and eventually nearly 5 million laborers came to the U.S. under the program, which ended in 1964. But the stream of Mexican labor continues today, often illegally. This ready supply of low-wage farm labor often reduces the grower's incentive to mechanize the harvest. And for the workers, the physical price of bending and lifting heavy loads is often very high. For them, a field of study known as ergonomics is making life better. Ergonomics focuses on the capabilities and limitations of the body in relation to a specific job, then tries to reduce heavy loads and prevent injuries from poor posture and repetitive motions.
We say, well, are there ways that we can give them better tools? Are there ways that we can allow them to do less bending and twisting? Are there ways that we can have them not lift loads at all or not lift so much of the loads?
The hand harvesting of lettuce was a difficult job that ergonomic studies began targeting in the 1970s. The mass harvest of lettuce still requires a bend and cut motion, with the worker trimming the outer leaves. But in the days prior to ergonomic study, workers packed the heads in heavy boxes and hand lifted them onto trucks. Back injury was a constant problem. At Dole Fresh Vegetables in California's Salinas Valley, a harmonious union of man and machine increases productivity and removes the worst physical stress. Like a giant factory on wheels, the lettuce harvester creeps slowly through the field as two-person teams pick and package individual heads, wrapping them in bags and placing them in boxes. Once a box is filled, a power assist roller helps the worker place it on a staging line.
The loader used to have to pick up the 40 to 50-pound box from foot level and put it up on top of the deck. Now that's being done automatically by a conveyor. We used to have somebody get out there and staple boxes shut. We now have that automatic taper, which as we've conveyed the box up on top of the deck, automatically shuts it and tapes the box shut.
For restaurants or institutional customers that require unwrapped or naked lettuce, a second harvester uses a precision pack method. Here, the lettuce is actually machine packed prior to its journey for post-harvest cooling. The labor-assisting devices in the lettuce harvest help Dole workers achieve an output of 5 million pounds of iceberg lettuce in a single week. But in some harvesting operations, ergonomic solutions are often surprisingly simple. The hand harvesting of wine grapes has changed very little over thousands of years. Workers cut the stems with hooked knives and place the bunches into bins. In field surveys, ergonomics researchers found that almost 60% of grape pickers suffered from persistent back pain.
So we said, well, what is it that we can potentially do about this lifting job? Then one step is we could eliminate the lifting. Another step is, well, suppose we don't eliminate the lifting, but we just reduce the amount of weight they're lifting.
A full bin of grapes weighs 57 pounds on average. By designing a smaller tub to decrease the weight by just 11 pounds, injuries were reduced by 80%, with no noticeable change in productivity. The development of a mechanized grape mover, which mechanically lifts and empties the bins, is removing even more of the weight burden and speeding up the harvest. Because grapes are such a delicate fruit, hand harvesting is the desired method. However, a 400% increase in wine production in the last 30 years forced growers to consider a mechanized solution. The challenge, of course, in mechanically picking grapes is in doing so without bruising or damaging the fruit. The Corvan Orborotor harvester applies gentle vibration as it passes over the vine row. Nylon rods with rubber cushions penetrate the dense canopy. The rods oscillate at 700 to 1,000 strokes per minute in a circular motion. The gentle vibration causes the ripe bunches to release and fall straight down without damaging the grapes.
The idea of this is to simulate hand harvest to be as close as hand harvest for the premium and wine grapes and do the least amount of damage to the vines.
When the grapes detach from the vines, a conveyor captures the bunches and transports them on a series of conveyors. A fan system blasts the grapes with air to remove the leaves and other debris.
By doing this, the only thing that we're picking is the berries. No leaves and no damage, and we're putting them straight into the bin. It makes this easier for the winemakers because they have less foreign material to pull out, and it's just straight product that can go right into the press.
Depending on the grade of wine and the speed setting, the harvester is capable of picking anywhere between 3 to 30 tons per acre in a single hour. Such high capacity is a big advantage, but the rougher handling compared to the hand harvest can cause greater damage to the fruit. When the juices leak from damaged grapes, there is a greater chance for contamination, ultimately affecting the winemaking process. What the mechanical harvester has done for grapes is even more pronounced in the labor-intensive raisin harvest. The tried and true method used to involve hand-picking the fruit and wrapping them in paper rolls for protection. The raisins were sun-dried in the field and periodically turned over several weeks before retrieval could begin. A new mechanized technique called continuous tray harvesting duplicates the technology of the wine grape harvester while eliminating the long and expensive process of hand picking and then turning the raisins.
The raisins are laid out on a thin sheet of paper, which is a 1/4 mile long usually, and a berry and a half thick. And what this allows us to do is get a consistent drying with no dirt and no human touching our raisins, and we're going for pure quality.
Cost-effective harvesting has built a strong case for mechanization. But the struggle between low-wage labor and the changing face of agriculture is a battle that is far from over. As science pushes the envelope in the fields of robotics and sensors, one wonders if the human hand may become obsolete in the coming high-tech harvest. Because raisins were so popular with Allied troops in World War II, their market price jumped from $48 per ton in 1939 to $312 in 1946. In the boundless orange groves of Florida, hand laborers work long months to harvest the crop. The vast majority of the fruit is destined to become orange juice. Unlike many crops bound for the processing plants, these oranges are still mostly hand-picked, and that's a cause for concern among growers. In Brazil, cheap labor is threatening to price Florida right out of the business.
The Brazilians can produce orange juice and deliver it to the United States with a 20% tariff imposed on them by the United States and be cost competitive with Florida orange juice. And so the growers are looking at the real possibility that if they can't reduce their costs, they're going to be outcompeted in the market.
They've basically decided in Florida that they cannot compete on a worldwide basis unless they have a mechanized harvest.
Mechanizing the harvest would theoretically reduce the growers' harvesting costs. Until recently, an ample supply of low-wage labor kept Florida competitive. But the price of labor has increased, and a crackdown on illegal immigration is causing a labor shortage. The Florida Department of Citrus is conducting research into the daunting task of mechanizing the orange harvest. Various canopy shakers, shake and catch, and trunk shaking machine prototypes were evaluated in field tests. The best are able to reduce the cost per field box by 20 to 50% over hand picking. But many obstacles remain. In some cases, orchards must be redesigned with a uniform distance between trees to accommodate the large machines. And because so many orchards are small and independently owned, coordinating the mass effort will require time and patience. Florida oranges are but one example of the changing face of harvesting. Today, science is testing a host of new technologies to gather crops and ensure higher quality. Sensing technology is promising more precise quality control of the harvest. One scenario envisions offering consumers a better quality product with high-tech sugar sensors.
So that we want to develop a premium label, a batch of fruit that is guaranteed to be very high quality, and so the harvester would collect that and put it in a separate container. So you would have a standard quality and a very high quality crop.
Creating a caste system for fruit, of course, might be a mixed blessing for consumers, driving prices way up on the high end. But other sensor technology currently in development promises to bring prices down. A device known as the electronic nose contains 32 electric-chemical sensors that simulate the human nose. By detecting the gas emissions of an orange, the nose is able to detect freeze damage, a devastating event that ruins the value of a crop. Being able to separate freeze-damaged oranges from healthy ones could save the industry millions of dollars in crisis years. Cost containment has always been the driving force of mechanization. Today, it is even threatening to take the farmer out of the combine. Named after the Greek goddess of the harvest, Demeter is a computer-controlled harvester equipped with a pair of video cameras and a global positioning sensor. This autonomous harvester is capable of harvesting crops more efficiently without the fatigue issues of a human-operated machine. Its precise guidance system turns the machine to cut successive rows in a non-stop operation while maintaining a straight-line accuracy of plus or minus 3 centimeters. The video cameras ensure that unexpected obstacles are avoided. In the even more challenging realm of fruit crop harvesting, the desire to replace the human hand is also fueling a move into robotics. In labor-challenged countries from Europe to Israel, robotic harvesters are an enchanting vision. But because of high costs and slow development, few of the robots are in full-scale production. But the technology is here to stay.
You're going to see in the future robotic techniques coming in that will try to simulate the quality that a person can harvest with. So you'll see in the future robots that can harvest a strawberry without bruising it, or harvesting a ripe peach without bruising it.
As we peer farther into the 21st century, the tide of globalization will continue to play out in the farm fields. While machines maneuver to cut costs and satisfy production goals, armies of farm workers struggle to find their place in a changing landscape. The collision of high technology with tradition has always been difficult, but the revolution started by McCormick's famous reaper has never stopped gaining momentum.
You have to remember that Cyrus McCormick's epitaph was, "He made bread cheap." And in an age when people were starving, someone who made bread cheap was someone who made an enormous contribution.
But could Cyrus McCormick have foreseen the firestorm of technology his simple reaper would initiate? In its never-ending quest to cut costs, mechanization has pushed the boundaries of science and transformed the age-old ritual of the harvest into a frenzy of accumulation, a literal shakedown of the world's orchards and farm fields. What the future will bring to the harvest is anybody's guess. But the ever-evolving relationship between man, crop, and machine will ensure more than ever that humanity reaps all that it sows.